Morning, one and all. I am Tarun from CSAB. My topic is catchy consistency. Before going to the catchy consistency, let us discuss what is catchy. Catchy is most regularly used data that is being stored mm, before accessing to the main memory. That is, catchy is data which stores to perform better. Here, catchy consistency is a problem in any data shipping system that moves data to the clients. Generally, it is a unique way that comes in object DBMS in client server systems. Study of DBMS catchy consistency is very tightly coupled with the study of concurrency control. Since catchy data can be concurrently accessed by multiple clients and logs can also be cached along the data at the clients. Now let us go to the next part. Catchy consistency is uh, algorithms can be divided into two types: avoidance based and detection based. As the avoidance based suggests that prevention, and detection is it allows, but at the commit time it checks. It's a validation step in detection based algorithms. Here, let us go to avoidance based algorithms. It prevents the access to the stale cache data. Here, stale data is an artifact of caching, in which object in the cache is not most recent version committed to the data source. So, to remove the stale data, we perform logs. Now let us go into the avoidance based. It prevents the access to the stale cache data by ensuring that clients cannot update an object if it is being read by other clients. It avoids another clients to update it when one is using this data. It ensures that stale data never exists in client caches. Detection based algorithms. These algorithms allows the stale cache data, but at the validation at the evaluation or commit time performs a validation step. It detects. Now let us jump to the avoidance based and detection based algorithms. Avoidance based and detection based algorithms are broadly classified as three types: synchronous, asynchronous, and deferred, depending upon that they inform the server at right operation being performed. Let us discuss about the algorithms: synchronous, asynchronous, and deferred. In synchronous algorithm, client sends request or escalation lock escalation message at the time it wants to perform a write operation. It blocks the server response. It blocks until the server gets response. Sorry. In asynchronous algorithms, client sends a lock escalation message at the time of its write operation, but it does not block. It optimistically continues. In deferred algorithms, the client optimistically defers informing the server about its write operation until commit time. In deferred mode, the client group all their lock escalation requests and send them together to the server at the commit time. So here the communication between the client and server a bit lower compared to synchronous and asynchronous algorithms. Now these all results uh, avoidance and detection based classified into six algorithms: avoidance based, synchronous, asynchronous, and deferred algorithms, and detection based, synchronous, asynchronous, and deferred algorithms. Before going to the six algorithms, let us discuss some of the points, main points. Majority performance studies shows that uh, to access they have conducted that strength and weaknesses to various algorithms are being conducted. In general, for data catching systems, inter-transaction catching of data and logs is accepted as performance enhanced optimization. The 3 points: data catching systems, inter-transaction, and inter-transaction catching of data logs is accepted as performance enhancing optimization because it reduces the number of times a client communicate with the server. On the other hand, for most user workloads, invalidation of remote cache copies during updates is preferred. Propagation of Over propagation of updated values to the remote client sites. Remotely, it can be more beneficial rather than going to that client page and updation. Here, hybrid algorithms that dynamically perform their invalidation or update propagation have been proposed. It dynamically performs. Furthermore, ability to switch between page and object level locks is generally considered to be better than strictly dealing with page level locks because it increases the level of consistency. Now, avoidance based detection, avoidance based synchronous algorithms. Example for this avoidance based synchronous algorithm is callback read locking is most common synchronous avoidance based catchy consistency algorithm. In this algorithm, client retain read locks across transactions, but they relinquish write locks at the end of the transaction. The client sends lock request to the server and it blocks until server responds. If the client requests a write lock on the page that is being cached at other clients, the server issues callback message requesting that remote clients relinquish their read logs on the page. These callback read CBL ensures a lower abort rate and generally outperforms deferred avoidance based, synchronous detection based, and asynchronous detection based algorithms. Avoidance based asynchronous. These do not have the message blocking overhead present in synchronous algorithms. Clients send lock escalation message to the server and continue application processing. It optimistically approaches such as this face high abort rates, which is reduced in avoidance-based algorithms by immediate server action to invalidate stale catchy objects at remote client as soon as the system becomes aware of the update. Asynchronous algorithms experience lower deadlock abort rates than deferred avoidance-based algorithms. Avoidance-based deferred optimistic two-phase locking of catchy consistency or deferred avoidance based algorithms. In these algorithms, the the clients batch their lock escalation message requests and send them to the server at the commit time. The server blocks the updating client if the other clients are reading the updated objects. Now, detection based synchronous, asynchronous, and deferred algorithms. Now, let us discuss about detection based synchronous. Catchy two-phase locking is a synchronous detection based catchy consistency algorithm. This example of cat C2PL is is a synchronous detection based algorithm. In this algorithm, catchy clients contact the server whenever they access a page in their catchy to ensure that the page is not stale or being written by other clients. Now let us go to detection based asynchronous. No wait locking with notification is an example of asynchronous detection based algorithm. In this algorithm, the client sends lock escalation request to the server, but optimistically assume that their request will be successful. But after client transaction commits, the server propagates updated page to all other clients. They have also cached the affected page. It has been resulted that CPL outperforms the no wait locking algorithm. Detection based deferred adaptive optimistic concurrency control AOCC is a deferred detection based algorithm. AOCC distributed object DBMS outperform callback CBL algorithms even while encountering a high abort rate if the client transaction stale completely fits into the catchy client catchy and all application processing is strictly performed at the client's purely data shipping architecture. Since AOCC uses deferred messages, its messages overhead is less than CBL. Furthermore, in a pure data shipping client or server environment, the impact of aborting client on the performance of other clients is quite minimal. These factors contribute to AOCC's superior performance. Uh, Thank you.
Yes. Good afternoon, everyone. Today, my topic is about catchy consistency and its performance characteristics. So, first, what is catchy consistency? Catchy consistency is a problem in any data shipping system that moves to the clients. So, before knowing about catchy consistency, first we have to know what is catchy. Catchy is like a separate system, like it is like a materialized partial view of the original data. So, this the study of DBMS catchy consistency is very tightly coupled with the study of concurrency control. Since catchy data can be concurrently accessed by multiple clients, and logs can also be cached along with the data at the clients. Here, if one user is reading the object, and other can update it. Other can update the object, or else if the user is reading the object, then other may not update the client. There are two ways to do in this. So these DBMS catchy consistency algorithms are classified into two types: avoidance based and detection based. So first, what is avoidance based? In avoidance based algorithms, they will prevent the access to stale catchy data by ensuring that clients cannot update an object if it is being read by other clients. Stale catch data means old data. Like here, when an client is updating the data, other cannot read that data. So they ensure that the stale data never exists in client caches. And next one is detection based algorithms. These detection based algorithms allow the access of stale cache data. In avoidance based, they prevent the access, but in detection based, they allow the access of this old data. Here, client can update their objects that are being read by other clients. So these algorithms are further classified into synchronous, asynchronous, and deferred. So based on these alternatives, we will discuss about the performance characteristics. So there are six performance characteristics. So first one is avoidance based synchronous. Here we use a callback read locking algorithm. Here in this algorithm, clients send lock requests to the server, and they will block those requests until the server responds. Next one is avoidance based asynchronous. In avoidance based asynchronous, even there is here there is no message blocking. If the client send any lock request, they no need to there is no need of blocking the request. Here they can continue their application processing. Next one is avoidance based default. So here we use optimistic two-phase locking algorithm. In these algorithms, what will happen is clients batch their all the requests, like they'll group all the requests and then send them to server at commit time. So then the server blocks all the updating client if the other clients are reading the updated objects. Next one is detection based synchronous algorithm. Here, catching two-phase locking algorithm is used. In this algorithm, clients contact the server whenever they want to access any page to ensure that page is not written, like not written, or it is old, not written by the clients, or it is old or stale. Next one is detection based asynchronous algorithm. Here, no wait locking algorithm is used. In this algorithm, clients send